Hi, welcome back. Today we're talking about perfect cubes and their applications. So in a previous lesson we talked about square roots, and square roots were just what times itself gives you the number underneath the radical. So if you have a 3 on the outside, like we do in these 3 examples here, that means it is a cubed root. So we need to know what times itself 3 times gives us 8. So you can guess and check to start out when you're first starting these, or if you know that 2 times 2 times 2 gives you 8, you're good to go as well. So the cubed root of 8 is positive 2. Let's look at another one. So again, this 3 here is called your index. That 3 means what times itself 3 times gives us negative 27. So we know this is negative on the outside for the 27, so our numbers are going to all be negative. And what times itself 3 times is 27? Well, let's try 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is indeed negative 27. So negative 3 is your cubed root. And for our last one, again, this is very similar to what we did before. If your fraction underneath the radical can't be reduced, we want to break it apart. So this is the cubed root of 1 over the cubed root of 64. So the cubed root of 1, what times itself 3 times gives you 1. Well, that's probably my favorite one. It would just be 1. And then what times itself 3 times gives you 64. So we know that a 2 was the cubed root of 8, 3 was the cubed root of 27, so let's try a 4. So 4 times 4 times 4. 4 times 4 is 16, 16 times 4 does indeed give us 64, so the cubed root of 64 is just 4. So in our next slide, we are going to create a table to recognize all of these common perfect cubes to help us out. Okay, so in our notes, we have this table set up. I did fill in a few to kind of give us an idea of where everything's going to go and work from there. So I have the cubed root of 1, so that cubed root is just 1. So I'm going to show you how to go back and forth between these. They're very interchangeable. You'll probably hear a lot of the terminology just thrown around. But remember, if it has a 3 in the front, it's a perfect cube. So this 3 is just what times itself 3 times gives you that number. So we did the cubed root of 8 in our previous slide. If you remember, that's just 2 times 2 times 2. So that is the cubed root of 2. So if I gave you the 3 here, we want to work backwards. I want to find out what its cubed root would look like for the perfect cube. So this is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So the cubed root of 27 is equal to 3. We'll do the same thing for 4. It's 4 times 4 times 4. Which we did previously gave us the cubed root of 64. So if you look at the pattern here, we are just creating a simple chart to be able to look back and forth at. So the cubed root of 125, you probably guessed it by now, is 5 times 5 times 5. So the cubed root is 5. So let's fill in the rest of our chart, just like we did before. So the cubed root of 6 is 6 times 6 times 6. So 6 times 6 is 36 times the 6, which is 216. Let me fill it in just like that. So the cubed root of 343 is 7. The cubed root of 512 is 8. And then to find 9, we do 9 times 9 times 9, which gives us the cubed root of 729. And last but not least, we have the cubed root of 1,000, which is just 10. We could definitely extend this further, but I just wanted to give you a little short rundown of common ones that you will see in our lesson. Let's move on. Okay, let's look at a few examples. Evaluating expressions involving cubed roots. So just like we did previously, we are going to look at our root piece first and apply order of operations. So if we look here, we have the cubed root of negative 216. Well, from our chart, we know that 216 is the cubed root of 6. So this would be 2, and we have a negative there, so negative 6 minus 3. So you replace it with its value and make sure that you're multiplying, just like we did with our square roots. So 2 times negative 6 is a negative 12 minus 3. The signs are the same, so you just add them and keep the sign. It's that easy. Now, part B here is a really cool scenario that we talked about before. The cubed root of the cubed root of 125 is 5, but then 5 cubed is 125. So just like when you had a square root of, say, 9, and you squared all of that, the cubed root and the cube cancel each other, just like a square root and a square cancel each other. Now, we did talk about that in detail, but I will leave that right there. All right, our last example for today, evaluating an algebraic expression. So what you want to do when you have something like this and it says when x equals, you are literally going to take that value in and plug it in wherever you see an x. So I see 2 of those right here. So I have 192 divided by 4 plus the cubed root of 192 divided by 3. Now, I know 3 isn't a perfect cube, so I actually want to deal with what's underneath that radicand first, and that's the 192 divided by 3. So 192 divided by 4 is 48, plus the cubed root of 64, because 192 divided by 3 gives us 64. Now that's something that we can work with. The cubed root of 64, we learned, was 4. So this really becomes 48 plus 4. Same signs combine, and we get 52. All right, to wrap up today, I want you to complete the Now You Tried numbers 1 to 6 in your packet, and you will go on Go Formative once I have checked these and you're good to go. Take your time, look back at your notes. If you need to rewatch anything, please do so.